Solving systems of equations can get pretty tedious when you have a lot of variables, or you're working with a lot of equations, and there's a ton of different methods for solving them. You can use matrices. You can use the method we're about to use, where you eliminate one variable at a time. But whatever you choose to do, you have to make sure that you have as many, at least as many equations as you have variables, or else you're not going to be able to find the values of the variables at all. So we're going to take these two equations here and see if we can solve for an x and a y that will satisfy both of these equations and make them true. And the method we're going to use is just simple isolation of a variable, one at a time. So we have two variables now, and what we're going to try to do is make it so that we only have one, and we can get a value for that variable, and then plug that value back into the original equation to get the other variable. So let's start with this bottom one here, since x doesn't have a coefficient, and solve for x. So taking this negative 4y over to the other side, we're going to have x equals 6 plus 4y. Alright, so now we know what x equals in terms of y, and we can plug that value back in for x in the first equation and solve for y in order to get a numeric value for y. So let's plug this back in for this x up here. So we have 3 times this quantity, 6 plus 4y, we're taking this down, plus 2y equals 4. Alright, distribute through 18 plus 12y plus 2y equals 4. And then combine like terms, 14y equals negative 14. And we get y is equal to negative 1. Alright, so now that we have y is equal to negative 1, we can plug this back into any of these equations and find out what x is equal to. So let's just plug it back into this one here. Since we know y is negative 1, we can say x is equal to 6 plus 4 times negative 1, or minus 4. X is equal to 2. So we know y is equal to negative 1 and x is equal to 2. And if we plug those numbers back in for the original equations, we'd see that they satisfy both of those equations. Good idea.